Can everyone hear me okay? Okay, awesome. First of all, very good morning and warm welcome to everyone. Our safe harbor slide won't go through that. Thank you so much. Thank you for joining us in person and anyone watching it online as well. Thank you so much. I'm Vandana Nayak. I partner with our customers on their data, AI, strategy, and architecture. And I'm joined by...
Hi everyone, I'm Kunal. I'm on the Data Cloud product team, and I primarily own multi-org strategies and admin and setup services for Data Cloud.
Thank you. So what are we going to cover today? We are going to talk about Data Cloud best practices for Agentforce. How does Data Cloud power Agentforce and what are those considerations from an architecture perspective? We'll start with the introduction for Salesforce platform and Data Cloud, how Data Cloud powers all of Salesforce different clouds and functionality as well. Then we'll double click into architecture considerations where we'll talk about data cloud provisioning, how to provision data cloud, what orgs to use, and governance, very important, especially in the AI world, and also about data connectivity and data management. Then we will also touch upon Agentforce, how do you ground agents with the data. Then we'll follow that up with the customer story. We'll talk about how Salesforce is using all this functionality and what are the considerations we had to take when implementing it for Salesforce. And then we'll wrap it with some key takeaways around how do you implement it in your organization? What are the considerations you need to have to make it successful? So with that, all right, what better way to start this session than a good old architecture diagram, that too layered architecture, right? As you see here, this is our platform architecture, which is powering all the applications, all the industry clouds, different functionality, flows, all the capability that is running on Hyperforce. And what is really key here is, as you see, Data Cloud, which is powering the data. The data is critical for every functionality this platform supports. This is where Data Cloud comes in. This is the foundation for bringing all that data together, accessing the data, making it available at the right time, at the right place, and for the right folks, making sure there is access controls as well. That is what our Data Cloud provides, the backbone for our Salesforce platform. How does Data Cloud really work? As you see, it connects data from multiple different sources, be it Salesforce applications, be it your external applications, different data lakes where our customers normally store their data, especially from a customer data or any transaction data, and also another one, unstructured data, which is becoming really more and more popular and more necessary, especially when helping the customers look up the information. So the unstructured data, when we talk about unstructured data, it's your PDF, it's your voice recording, call recording, it could be video files, free-form comments, all of that data, bringing that together, all the different functionality that we provide to access all this data, create that customer profile, and govern that data for AI, and then creating the insights around the data from that data, and more importantly, making it accessible, be it for your internal human agents or digital agents, digital support agents, making it available for those agents as well as apps. That's what Data Cloud provides at a very high level. As you see, this is the Data Cloud capability map. You can say it's overwhelming. It can be overwhelming because it provides so much functionality right from the connectivity perspective and all the way to making it actionable and from an analytic perspective. When you have so many capabilities that are provided, how do you get started with this? This is where use cases come in. Very critical to think about the use cases. Start with the use case that you need to implement, that what is important for your business, what is that most critical problem your business is trying to solve. Start with the use cases. So I'll walk you through an example. This is for a media company. For them, creating the 360 of their guest was very critical because that's what is needed by their cast members to help their customers and guests. These are the capabilities, as you see, was important for that specific use case. The ones that are highlighted in blue are the ones they prioritize for their use cases. These are the ones we start with. And also the way data cloud is architected, it's very composable. It's very open architecture. So you can start with those couple of use cases or key use case and then build upon this. It's not that you have to enable all these capabilities right away. Start with small and then be strategic about what data you are bringing in, have the right architecture for that, bringing in the data, right data pattern, and then extend it for additional use cases. How does the architecture look like? For the use case I mentioned, this is an example solution architecture. As you can see, they have data sitting in their Snowflake, which is more of the data lake. And how do we bring that data? Here we are also talking about real-time data, bringing that in, bringing into data cloud and making it accessible for service cloud and agents in this scenario. So this is an example architecture of how data cloud fits in to meet a specific use case. For this specific example, I'm covering the media use case that I mentioned about. As you see, we are talking about unstructured data as well here and making it accessible for customers from a different channels as well as for the agents with the call summaries and recommendations, summarizing the cases, all that functionality made available through this sample architecture. With that, we will start with some of the architectural considerations.
Thank you, Vandana, for giving an overview of Data Cloud. So just for this session, we are going to go a little bit more deeper and really walk you through different steps of your Data Cloud journey and what are the architectural choices. So first and foremost, one thing we all need to understand is Data Cloud is now required with each and every Salesforce org. And that's primarily because your sales, service, marketing, all these clouds that are built on top of Salesforce have features now depend on Data Cloud. And that's primarily because Salesforce, as in earlier, which had the transactional database, cannot support the big data scale and the AI analytics, etc. So that is where these features directly store their analytics, their feedback, their a lot of Data Cloud related conversational real-time data directly into Data Cloud. And that's why Data Cloud needs to be front and center of your architecture thought process going forward for all your Salesforce orgs, whatever that might be, if it's one or multiple. With that in mind, first question comes to mind is, where do I provision Data Cloud, right? For our multi-org customers, they generally don't want more than one Data Cloud as well, right? You don't want to create multiple single source of truths across your multiple orgs, as well as even if you are a single org customer, the big question comes is, where do I provision it in my current org or another org? So there are a couple of things to think about first of all. First thing is obviously data residency and compliance requirements. Data Cloud is a separate tenant today, which gets provisioned associated to your core org, wherever, if you created in a Salesforce org also. And Data Cloud we currently support around 14 plus regions in AWS. So if you have any data residency requirements and you want it in a certain AWS region, I would highly encourage you to first check the mapping of your core org with the Data Cloud region associated with it and consider that into a factor also. At the same time, when architecting it overall for latencies, for your Agentforce requirements as well, think about what are the legal compliance requirements, especially in a multi-region ecosystem that you may have in your enterprise architecture. Secondly, data processing for everything that happens in Data Cloud will happen in the AWS region associated where Data Cloud has got provision. So again, data processing is not happening in your core org, wherever that region is. It's happening in the Data Cloud region specific to it. And that region is easily available to you. You can see it on your Data Cloud also, where your Data Cloud is currently provisioned. Some of the other things to think about for everyone. Last but not the least, often we, when encounter this question of where to provision Data Cloud, we start talking about administration and control. Now, traditionally, Salesforce users or Salesforce admins have been more catered towards the businesses. But when Data Cloud comes into the picture, we also start talking to the IT persona or the IT teams of the organization, creating the single source of truth for their data organization in Data Cloud. So who owns that? Are you going to be implementing multiple for your each Salesforce org if you have multiple? Or is it going to be a centralized place? And where will it be provisioned? That becomes another consideration to factor in, as well as get alignment within your organization. With that, keeping in mind those considerations, first choice whenever you are on your Data Cloud journey is, where do you provision your Data Cloud? right? And currently the terminology that we're using, home org is where we are saying is data cloud is getting provisioned. So you need to think about, where do I provision it? One of the choices is that I have 4 orgs, for example. I just provision it in one of my existing orgs, and that becomes my single source of truth for all my existing orgs, right? And then you share data across all of those orgs. Another way to think about it is that sometimes organizations want a separate control and want to keep data cloud in a unique org itself, and they end up creating it in a separate org altogether. So this is the first choice generally our customers end up making, and something organizations should think about rather than just going with the default behavior. Next comes into picture is for customers who have multiple orgs. How many of you have more than one Salesforce org right now? Oh yeah, quite a few. So if you have more than one Salesforce org and you want one data cloud around it, what are the patterns for it? With that, so we released a new feature called Data Cloud One in October last year, and without that, the two patterns that we had on the left hand side are, you have a Data Cloud home org. One ways is that if you have 3 orgs, all 3 of them become data cloud home orgs. Basically, you have 3 data clouds and you are ingesting your structured and unstructured data multiple times from external systems to these 3 orgs every single time. That's one way. Not the best effort. I mean, it's duplicative cost, duplicative effort. Maybe you don't want to do it. Another way is you just query it from one of the orgs that doesn't have data cloud, but that doesn't help your local applications that are getting built on in that org. If you have a sales cloud in standard org 2 over here, and they want to use one of the native features from data cloud, they'll not be able to do it easily and you'll have to write cross org API calls in order to access data cloud data from the home org. So this is where Data Cloud One really helps that architecture. What we really do in a nutshell is we share the metadata of the objects that you want from your home org to companion orgs. So data spaces becomes, which is another concept that I'll talk about later on. Data spaces becomes a sharing unit where you can share metadata from your home org to companion orgs. Your data gets still stored only in one org, which is your home org. This way, all your orgs connected with the connective tissue of Data Cloud One have one data cloud behind the scenes. All of them have the same access level for data cloud, and everybody is working on a shared repository of data. This also solves our multi-org problem for Salesforce, which has been there for many years. Now, when you're considering Data Cloud One, what are the key things for you to factor in? Obviously, consult your legal advisors, because you may be moving data from cross-region boundaries as well. Number 2 would be keep the growth in mind, right? Like, even if you started in one org, what if multiple orgs end up saying that, hey, I also want end-to-end control of my data cloud. So this is where administration and control and getting alignment at an enterprise level within your organization is extremely important upfront itself, so that you know what is your tenancy for data cloud going forward with Salesforce. Now, just going a little bit more into it, there are 2 types of connections that are available in data cloud today when interacting with other Salesforce orgs. One, which we just briefly talked about, is Data Cloud One companion connections. And the other is standard connection, which has been there all along. So now the difference between them is standard connection allows you to ingest data into data cloud. It's a one-way connection where you can bring in all your data into data cloud. You create your data model, you do identity resolution, and you have your single source of truth in the home org. Now that view is not natively available to your other org where you have ingested data from with standard connection. With companion connections with Data Cloud One, you not only can ingest data into data cloud, you also share back the metadata of the unified objects into your companion org. So in many ways, both home org and companion orgs have the same amount of access to your data cloud orgs. Now, as I talked about earlier, within Data Cloud One, data spaces is the unit of sharing, right? So this brings us to our next topic beyond provisioning is data governance. Now, within data governance, it's extremely important for you to also think about within your enterprise architecture on how you are gonna give access to different sets of users to within data cloud access to the data, right? So there are different ways to partition that data. One of the ways is data spaces, which has been there for 2 years as a GA feature. What data spaces allows you to do is bring your data into data cloud as data lake objects. Then you can partition them, and you can have separate for different brands, for different departments. You can have absolutely different silos as data spaces. Data space 1 could be, for example, sales. Data space 2 can be service. And you can create a different data model for them altogether. You can filter data within them as well. But the interesting part is then they are operating completely uniquely in their own silo. The good part about it is that you can say Kunal has access to data space 1 completely and does not have access to data space 2 completely. So that way you can also manage the access control around data spaces for your users. That's where the governance control becomes a key aspect. A lot of our organizations end up dividing that data for employee versus customer data, because you never want them to get mixed up, as well as you don't want same audiences to look both of them under the same context. Beyond data spaces, there is a lot more controls that we have now added to our data governance layer. So beyond data spaces, now we have AI-based tagging and classification, which was recently gone in beta. With that, we also have access policies and policy-based governance. So this will be the next level of granular access control that you can manage within a data space or outside of data spaces, right? This will allow you to define at a row level, object level, column level. You can add tags or classifications to it, and then based on those tags or rows, you can create policies saying my XYZ admin users have access to this tagged data. So this gives you the next level of control, which is a lot more granular in order to control your data governance. So there are 2 levels which we talked about: a macro level, which is data spaces, and a granular level, which is policies. You may not need both. You may need just one or the other, but a lot of the times you end up creating a combination of both based on your use cases. And this is the entire layer over here. So at the bottom, we have encryption. You can bring your own key. You can set up the encryption of whatever data is getting stored in data cloud. Number 2 becomes data space management. You decide whether you want one or more data spaces or not, and then plan the distribution of data within those data spaces. Number 3 and 4 is very much intertwined together, where you define your tags for your data that is coming in data cloud, as well as you can create policies on top of it. Now, recapping data governance to an extent, we talked about 2 levels: data spaces and policy-based governance. Data spaces, as I said, is a macro level concept which allows you to partition your data for your brands, for your different data models that you want to coexist within the same data cloud. At the same time, data spaces can be useful for you to do granular data sharing among your companion orgs as well. On the other side, policy-based governance is used for you to do row level, column level security and assign different access controls to your different personas within an existing org. So that is the difference between these two. With that, I'll hand it over back to Vandana to cover other architectural considerations.
Awesome. Let's start with something that we all deal with every day, right? There is never lack of data. What is lacking is access to that data at the right time, right place, and right system. How do we deal with that? Sometimes it can be so frustrating to get to that data. That's where Salesforce Data Cloud provides several integration patterns to tap into that data, unlock that data that is stored in irrespective of whatever system be it on-prem system, be it in your data lake, or be it in another SaaS application. So we provide several integration ways, first one being the batch one, the good old way of getting the data in batch. When do you use it? This is ideal, especially when you are getting historical data, huge amount of data. That's when the batch integration, the data gets loaded into data cloud. Second one is around streaming. This is more of that event-based architecture where you want the data to be available in real time. As the events are happening, you want to access that events and make it actionable. That's where streaming comes in. Third one is we also have real-time pipeline, which is milliseconds. I'll double click on that and go through how that works. So third one is around real-time, which is also used by many of our customers, especially for this real-time personalization, hyper-personalization, powering those. And the fourth one, very important one, is how do you access that data without replicating the data into data cloud? Data cloud, our principle is not about bringing all the data into data cloud. It's not about data gravity. It's all about how you can maximize the data, value from your data, insights from your data, and make it available, accessible for the applications, irrespective of whether you are using Salesforce applications or your third-party applications, or be it agents too, right? So starting with the batch, this is where we provide APIs, the bulk APIs, as well as the APIs that you can use to really load the data, more very similar to the historical ETL process. This is where data gets loaded into data cloud. And when do you use it? Loading large amount of data, especially for that initial conversion. You want to load your customer data, which is one-time activity. Batch is perfect for that one. Or you have data that is not time sensitive. The examples we run into with our customers is like pricing, which doesn't change very often for retailers. It changes maybe not very often, periodically it changes. So batch data transfer, loading that data in batch is ideal example there. And as I mentioned, historical data as well. Many times they want to bring in the historical cases, case data, so they can run the analytics around that. Also calculate more insights about their customers around, okay, what is the lifetime value? What is their propensity to churn? They want to use that data from historical transactions, past history of those customers, and also past interactions. That's where this is another great example. And also we have cases where there is complex data transformations are needed. Batch is another, again, great suited for that use case as well. And what are some of the considerations here? Real-time insights. If you are looking to get insights real-time, batch is not the way to go. But again, you want to optimize the batch size as well. You don't want to have like hundreds and millions in one batch, because you want to make sure that the data, there is governance around how the data is loaded, were there any errors, was it all loaded successfully. So having that around batch size consideration as well, and especially with the data cloud being on the consumption model, you want to optimize the batch size for how much credits you are consuming as well. And also making sure that data quality checks, implementing those in the batch load is also critical. And moving on to the sub-second real-time architecture. This is the one where, as you can see, in real time through SDKs, data, as the interactions are happening, as the clicks are happening, as the customers are clicking through something, or as they are looking through a web page, in real time that data is ingested. And not only that, the powerful here capability here is in real time identity is resolved as well. I may be looking at CNN.com, but I may be using a different profile to go through that CNN.com. In real time, it ties in with my prior record, prior customer data that is stored in Data Cloud, and resolves to know that, okay, it's the same customer. That way you can have advertisements to that customer that is catered based on my prior interaction, based on my prior history, prior calculated insights as well. All this happens in real time, sub-milliseconds, under 200 milliseconds. And this is a common pattern we have a lot of our customers using. We have a huge entertainment provider that is using this pattern as their customers are entering their park, as they are going through one ride to another. They are using this information to suggest other rides to that customer as well. And financial, this one is also used by several of our financial customers as they are looking through their website for different plans provided, savings plan or IRA plan, to provide those real-time recommendations, hyper-personalization. This is a pattern that is usually used by many of our customers as well. And I mentioned about hyper-personalization, fraud prevention. This is another common use case that we see with our customers, especially with a lot of retail customers, manufacturing customers as well. As customers are trying to buy something, making sure that it is a valid transaction and it's not fraudulent transaction. All this helps mitigate risk as well and also minimize the shrink. So this is something else where a lot of retailers are using this real-time pipeline for powering that use case. And we also have a major auto manufacturer who is using this use case to capture those IoT basically signals coming in. Is there anything wrong in the engine? Are there any messages coming on the engine? All getting that in real time and providing recommendations to that customer as they're driving. So this is another use case used by one of our auto customers as well. And you can also use it for instant event-driven analytics as well. So very powerful, as you can see. The users, lot of use cases that you can power using this integration pattern. What are the considerations? Low latency versus strong consistency. This is more of that fire and forget kind of architecture where in real time it's doing things, but it won't look into a lot of historical data because you want to really have that quick interaction, quick outcome here. So the latency over strong consistency, that is one consideration. And again, this architecture pattern does not support complex joins. If you want to join a lot of data DMOs within your data cloud, this will not support that. It gets very complicated, especially when you're trying to do that in real time. It will impact your latency. So I would not recommend having this, especially with complex processing as well. And large data graphs, keep in mind if you are powering large data graphs in real time, that will also increase your query latency as well and data credit consumption as well. Again, it's a balancing act between providing real time versus balancing the cost, right? If the cost was not in play, then yes, everything can be in real time. You want everything in real time. When cost is in play, you do want to balance. No one wants that surprise bill that you get from your provider, right? Then the third one, moving on to the data access via zero copy. Historically, we have used ETL, which is not fun, right? It's painful. You have to extract that data, transform the data, load that data, especially when you have huge amount of data. It requires a lot of work. And there are many reasons where you don't want to replicate all that data, which becomes very hard to keep them consistent as well, especially the more copies of data you have, which is your true version of truth when you have multiple copies. I have seen many customers, and I have run into this in my prior life as well, which is like we are always like, run reports against multiple sources, you get different outcomes. What is the right version to use? This is our, basically Salesforce pioneered this technology of zero copy, where you can access the data from your data lakes or other data sources without replicating that data into data cloud. And the good thing about this is bidirectional as well. Even the data from data cloud, you can access in your other data lakes for analytical purposes or any other use cases without copying the data over. Really efficient, provides you a lot of flexibility around accessing the data without replicating the data. And some of the use cases I see using this pattern are more around, you have your inventory data that is coming in from your multiple supply chain systems that is getting loaded into data lake. You don't want to create a copy of that in data cloud. That's where our customers are using zero copy from Snowflake or Databricks to access that data in real time. What are the considerations? Again, optimize query execution, because with this pattern, the query gets executed on the Snowflake or Databricks, basically. So you want to make sure that you are pushing the predicate and running the query, which is optimized and not accessing all the data all the time. And we also provide acceleration as well, especially if you have data that needs to be used multiple times. We provide acceleration, which is basically caching technology as well. And use efficient data file formats as well. Other thing to keep in mind is security access and governance. That will be something that will be managed on the data lake side. So even you are running this, making sure that the user who is accessing that data or for whom it is being accessed has the right access for that data as well. And also monitoring and for the ongoing, like how it is being used and optimizing that queries and by having the right constraints there. Key considerations here is basically data consistency and freshness, because data doesn't get replicated. You have the freshest data. It's as fresh as the data that is sitting in your data lake or the other systems. And storage and compute cost, because it will be all on the data provider side, not data cloud side. So that is something else to keep in mind as well. And then the word trust gets thrown around a lot, especially in the world of AI, right? Always we are like, okay, we want to make sure we can trust the AI. Can we trust the AI? That's the number one concern I hear from our customers is, okay, can we trust the AI? So how is Data Cloud facilitating this trust? It all comes down to data, right? Your AI can be only as good as the data it is providing. That's where data quality and grounding becomes critical, and that's what Data Cloud supports as well. And then being able to explain why the AI produced some results that it produced. End of the day, when you have agents running, it produces some results, you are liable for that. You have seen some instances, right, where airports or airlines have to explain why their AI produced that. So that's where Data Cloud provides that flexibility to store that data. And monitoring and model performance as well. Data Cloud facilitates that real time, making sure that AI is accurate, and security governance and privacy considerations, data masking and zero data retention facilitated, and also making sure that bias detection and risk mitigation. We provide functionality where you can maintain what are the different bias score and monitor that through out-of-the-box reports and dashboards as well. And there are different ways for grounding AI in your enterprise data. First one is merging the CRM field. Basically, at runtime, you can access the data from CRM. And you can also ground with flows. This is ideal for, especially when you're using complex logic, then you need to use a specific value, then you can use flow to provide that value. Ground your AI prompts with the flows. And around retrieval augmented generation, very powerful. This avoids the need for model fine tuning or basically training your models on huge amount of data. Calling APIs, especially when the data is sitting in external systems, that can be facilitated by calling APIs. And the data graphs, which is basically JSON with all the data, all the relevant attributes that you need to send to a prompt, that is supported as well. And unstructured data, how are we supporting? As you see, we provide several ways of chunking the data, storing the data, optimizing it, indexing it based on the use cases. Again, here are some considerations and best practices. Optimizing your data for retrieval depends on the use cases, right? If your use case requires frequent access to that specific type of data, index it based on that. And also search, what kind of search is it? Is it a hybrid search? Is it a keyword search? Or is it a semantic search? Depending on the search, index your unstructured data as well. And also ensuring data quality, especially when you have like a lot of knowledge articles is a good example. Our customers load knowledge articles all the time. How do you make sure they are kept up to date and AI is not going against outdated transactions? And different considerations here again, indexing strategy, query performance, and scalability considerations as well. And the last one is around hybrid search, where again, hybrid search is very ideal. We have a lot of customers using it when you have a search based on specific model, manufacturer, where you want to look at a specific refrigerator model or specific car model. That's when hybrid search comes in. It can look at the unstructured data for that specific model number or year as well. With that, I'll turn it over to Kunal for talking about our customer zero, which is Salesforce.
Thank you, Vandana. So this is one of the live agents that went out live in December itself. This is our own help customer success agent that we created. And I wanted to walk you through the architecture. I mean, this is one of the use cases that Salesforce has implemented out of all the agents and all the applications that are currently getting powered by Data Cloud for our own use cases. But just wanted to walk you through what did we do for this from a structure basis, as well as what are the architecture choices that we just talked about. How did we go through that decision making? Now, to create an agent as well as to create a knowledge hub within your organization for all the unstructured data as well as structured data. Just for our customer success, we had a lot of different data sources itself. You can see many logos over here where data was distributed in many ways. Nobody had access to everything. So first and foremost, we had to bring it all together. And that is where Data Cloud was the cornerstone for this entire architecture. On the left-hand side, you can see all the data sources that we had to ingest data from in order to create this customer success agent. Not just that, but a lot of other use cases that we had in mind for agents keeping customer success in front of us. And bringing it into it, Data Cloud was the first task. After that was how do we use it across different channels. And Data Cloud being an open and extendable platform, it supported us to access that data from multiple different channels and then power agentic experiences. Now, behind the scenes, this was the architecture. Now, Salesforce itself has many Salesforce orgs for our own customer businesses. Our businesses did not talk to each other for a long time as well. For example, our marketing has access to their own data sources. They are bringing it. They have their own Salesforce org. Sales being a different one, customer success being a different one. Now, first question, if you go back to the first part of our session, was where do we make our org a home org, right? Like, which is our Data Cloud home org? So we had a lot of internal discussions for 6 months at the leadership level, and we ended up choosing one of our existing orgs to become our home org, and that became our marketing org. So marketing org currently is our home org. Now, next step was, what are the companion connections we are creating? So all the other orgs that were there in Salesforce ecosystem ended up being companion connections instead of us creating multiple data clouds for our own architecture. And third was around what are the data spaces and what is the level of granularity that I'm sharing between my home org and companion orgs. So for Knowledge Hub, right, we created a common data spaces where we basically brought in all the public knowledge that is available in Salesforce ecosystem, and we put it in that common shared data space. And now that data space is available to all the companion orgs as well. For specific sharing to individual companion orgs, we created specific data spaces also along with it. You can see over here, there is a customer success, sales, revenue are some of the other data spaces that we created in home org, but not all of them are shared to each of the companion orgs that are currently connected to it. Right? So sales, we have shared only 2 data spaces with them, sales and unified public knowledge. For the customer success org, we have shared the customer success as well as unified public knowledge. And now with this architecture, customer success team, without re-ingesting all that structured, unstructured data, they can simply access all that knowledge hub that has been created from their own org and create an agent from their own org from customer success. So that's where that help website is getting powered from. Now, within this journey of customer zero itself, this was just one of the use cases. We have implemented many use cases, and there are a lot of learnings that we have had from that, right? One of the ones keeping Knowledge Hub and the help agent that we have created in mind is maintain your knowledge sources as well as you have to groom them continuously, right? Because there'll be archive data as well behind the scenes, and you don't want recommendations to come based on archive data. At the same time, keep your prompt engineering and prompts extremely simple. There is no need to overcomplicate it. Keep them very user guided and keep them simple, but at the same time, keep on refining them. Last but not the least is details are like during the initial setup, thinking about Data Cloud architecture and the setup associated with it is extremely important. We highly suggest you to have that enterprise level conversation up front. What happens otherwise is, in some cases, customers have ended up creating multiple data clouds, and then the process to combine all of them or deprovision some of them and merging it into one is an extremely painful task or a tech debt that organizations have already incurred. With that, we come to the end of our session. Few things to keep in mind for everyone, right? And this is our guidance to all our customers. Develop your data strategy. Set up a data center of excellence within your organization with the backing of your leadership across all your business units. Do not just limit it to your current business needs or business units. Set that up at least upfront, so that everybody's aligned that going forward, whenever they have any use cases based on data cloud, this is the architecture that we're going to adopt. Number two is start small. There's obviously a lot that you can do with data cloud on day zero as well, but think about, pick one use case which has some value associated or high value associated with it, and start over there and take it and scale upfront from there. Number three is data governance is going to be a key aspect for all our customers, and managing unstructured data and structured data in data cloud is a different muscle, as we talked about data spaces and policy-based governance. So upskill your admins should be knowing about this, and make sure that you keep on trailblazing in the data governance aspect at all times. With that, we'll end the session. Thank you for everyone for coming, and we'll take any questions. We'll be here around over here. If you have any questions, please feel free to ask us.